Hey guys, today we're talking about 2-1 using inductive reasoning to make conjectures. So, all of chapter 2 involves this idea of talking about proofs, which are a major component of geometry. Basically, just a way that we can rationally explain the different things we do in mathematics. So, we're going to start kind of slow, dealing just the introductory things, talking about definitions, patterns, how to explain those, and then eventually proofs are going to carry on through a little bit of each chapter through the rest of the year. So this first couple sections aren't too bad. Just pay close attention to the verbiage that we use and all the different definitions that we have. So that's the most important thing right now. So let's take a look. Our objective is to use inductive reasoning to identify patterns and make conjectures. Find counterexamples to disprove conjectures. So the first thing that we're going to do is we're going to simply identifying a pattern. So it says find the next pattern in each item. So we're going Monday, Wednesday, Friday. What is the pattern that's happening? And we can say that they are skipping a day or alternating days. So the next day would be Sunday. So that's our pattern there. Next we have a number pattern. It says 3, 6, 9, 12, 15. What's the next thing that we had? Most of you guys probably already said it. 18. And the type of pattern this was is these are multiples of 3. And that was the next number in line. And then our next one is actually a picture pattern. So we're going to look at what's happening in these pictures. Arrow going to the left, arrow going up, arrow going to the right. What do you think naturally comes next? An arrow pointing down. Let's do that in the color of red. So arrows going down. So, and the type of pattern this is we were rotating clockwise. So look at all the different parts of your pattern. That'll help you identify what the next piece is going to be. Now, a couple of definitions that we have coming up. It says when several examples form a pattern and you assume the pattern will continue, you are applying inductive reasoning. That's this first fill in the blank. Inductive reasoning. So inductive reasoning is the process of reasoning that a rule of statement is true because specific cases are true. You may use inductive reasoning to draw a conclusion from a pattern. A statement you believe to be true based on inductive reasoning is called a conjecture. So these guys up here that we used, we were able to use inductive reasoning to make a conjecture about what the next pattern was going to be. So that's kind of like how those words are used together. So here, make a conjecture, complete each conjecture. The product of an even number and an odd number is blank. So right now we don't know. So let's get a couple examples to help us think this through. An even number. So any even number, let's say 2 times an odd number 3 would be 6. Let's do another one. So let's pick another even number. Let's say 10 times an odd number would be 7. That would be, that's going to be equal to 70. And then another even number, let's say 20 times another odd number, let's say 11. That's going to be equal to 220. So what is the conjecture we can make here? Well, we notice that every time we multiply an odd and even number, our answer is always going to be, if we look at all these numbers, where they have in common, they're always going to be even. So that's our conjecture. Next, letter B. It says that the number of segments formed by n collinear points is blank. So this one has a picture. I didn't have enough room, so I'm going to draw the picture over here. So if I have a dot, a line, and a dot in the middle, a dot, 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 dot. And if it's hard to see, let me make those guys a different color. So I started with 2 endpoints, and 1 in the middle. 2 endpoints, 2 in the middle. 2 endpoints, 3 in the middle. So what do we think the next number is going to be? So let's look at the statement. It says the number of segments formed by n collinear points. So n means just whatever number is next in our pattern. So we have 2 points here, and I made 1 segment. Here we have 3 points, and it made 2 segments. Here we had 4 points, made 3 segments. And here we have 5 points, makes 4 segments. What do we think the next one is going to be? Let's see. The number of segments formed by endpoints is always going to be segments, the segment number, minus 1. So 2 minus 1 is 1, 3 minus 1 is 2, 4 minus 1 is 3, 5 minus 1 is 4. So, very good job. Example 3, biology application. To learn about the migration behavior of California gray whales, biologists observed whales along 2 routes. For 7 days, they counted the number of whales seen along each route. Make a conjecture based upon the data. So looking at this, we have route 1, we have 1302110 on the direct route, and then 7958868. So what is a statement that we can make based upon the data? So if we notice, this one has a whole lot more whales than the top one. So our conjecture would be there are more whales traveling along the shore. So if we picked the next day, you can use that statement and say the next day that we have, there's going to be obviously more whales traveling along the shore than along the direct route. So that's how statements are made. Now another thing that we have here is it says to show that a conjecture is always true, you must prove it. It's not simply enough to show an example, we have to prove it using statements. To show that a conjecture is false, you need to only find one example in which the conjecture is not true. And this case is called a counterexample. So very quickly, we can see that it's much easier to disprove something than it is to prove something. It's very easier to say something's false than it is to say that something is true. And the next is we have this little box can tell us the steps of inductive reasoning. It says look for a pattern, make a conjecture, and prove the conjecture or find a counterexample. Or find a counterexample. Okay. So show that each conjecture is false. So here they're telling us ahead of time, hey, these guys are automatically going to be false. So we need to find an example that makes these things false. So for all positive numbers n, 1 over n is less than or equal to n. So we need to pick a positive number that makes this statement, the next statement, false. So let's see. What are some positive numbers? 1. 1 over 1 is less than or equal to 1. But that's true. So this doesn't work. What about 2 or 3? 1 over 2 is less than or equal to 2. Well, that's true. That doesn't work. What about 3? 1 over 3. So, oh man, this looks a little tough. But remember, we're using positive numbers. We can use any positive numbers. So let's say n is equal to 1/2. If I divide 1 divided by 1/2 as less than or equal to 1/2, on the left side, this becomes the number 2. 1 divided by 1/2 is 2. And is 2 less than or equal to 1/2? No, this is false. So our whole statement is false. This is what our counterexample would be. Just one number. One number can disprove the whole thing false. For any 3 points in a plane, there are 3 different lines that contain 2 of the points. So I need to draw 3 points in a way where there are 3 different lines that contain 2 of the points. Okay, so let's think. So if I draw 1, 2, 3 points here, like this, I have 1 line, 2 line, 3 lines. So that makes it true. How can I draw these 3 points so that 3 lines do not appear? If I do 1, 2, 3. If I make them collinear, they're all on the same line. If they're all on the same line, then they can't be on 3 different lines. So this is our counterexample. So counterexamples can be numbers, like the first example that we have, or they could be a picture, like this example that we have down here. The temperature in Albany, Texas never exceeds 100 degrees Fahrenheit during the spring months of March, April, and May. So let's look here. Never exceeds, so it's March, April, May. Oh, May is our counterexample. May is greater than 100 degrees Fahrenheit. So our counterexample can also be something inside of our data. All right, thank you for following along, and if you have any questions, please leave a comment and let me know. Otherwise, I'll see you guys later.